Hi, my name is Kaylee, and I'll be presenting information to you on the uses of bee venom in medicine. To start, it helps to know basic makeup of bee venom. Bee venom may have a negative perspective from those who have endured the painful stings, but from ancient times until now, it has been used to treat a wide variety of ailments. So what is it that gives the venom these interesting medicinal properties? Bee venom is mostly water, which gives it the ability to disperse throughout tissues. There are 18 pharmacologically active components in bee venom, mostly phospholipids, amines, and enzymes. The main component of bee venom, and 50% of the dry weight, is from melittin. This is the main peptide that also causes pain from stings. Phospholipase A makes up 12% of the dry weight, also inducing pain and causing cell membrane destruction. Other major components include apamine, MCD, ethers, and sugars. Medicinal use of bee venom dates back to 500 BC in China. Ancient India, Babylon, and Greece also have records of recognizing the therapeutic use of bee venom, even though the science behind it was far from developed. There is also documented use of Hippocrates using bee venom for arthritis, which still is used today. In 14 BC, Pliny the Elder used bee venom to treat baldness, which also is still studied today, though science is less confident about the effects. In 1888, a European study published the connection on rheumatism and bee venom, and since then bee venom has been used for a wide variety of conditions. There are many conditions that bee venom has been used for throughout history, but without scientific literature, conclusions could not be drawn. Bee venom is currently used to combat allergic reactions to bee stings, and it is FDA approved with high success rates. Other popular areas of research include arthritis, multiple sclerosis, HIV, Alzheimer's disease, and cancer. Hippocrates was well ahead of his time with bee venom's connection to the joints. Today there is a large information base on bee venom's connection with both rheumatoid and osteoarthritis due to bee venom's ability to block pro-inflammatory cytokines. A 2005 study found bee venom to have significant effects on inflammation and pain both. Success rates are generally between 60 and 90%. Another area bee venom is used in is neurodegenerative disorders, particularly multiple sclerosis. One study had an 83% success rate with bee venom therapy for multiple sclerosis. Apamine and phospholipase are neuroprotectants that affect glutamate, a neurotransmitter. Test subjects primarily used for Alzheimer's disease are mice, which bee venom has shown clinically positive improvements with memory and cognitive abilities. Finally, the most controversial subjects of bee venom therapy, cancer and HIV. Methods to treat cancer are constantly a target of research in modern society, and bee venom has been one of the many substances tested. Melittin is recognized as a powerful anti-cancer peptide through cytotoxic abilities, but bee venom as a whole may do more harm than good. A 2012 study found melittin to be promising in animal tissue cells. HIV is also another heavily researched area for treatments, and bee venom has been a challenging topic here. Melittin has cytotoxic effects, but it also is not tissue specific. Therefore, it must be used in nanoparticles to kill HIV while leaving healthy human cells. Research and clinical studies are needed for both cancer and HIV. To summarize, bee venom has been used medicinally in both ancient and modern times. Bee venom is mostly water, but it has 18 known pharmacologically active components. The main component in bee venom besides water is the peptide melittin. This peptide and other components are important in treating conditions such as bee venom allergies, arthritis, neurodegenerative disorders, cancer, and HIV. Only bee venom allergy shots are FDA approved now, so research still needs to be conducted on these other diseases. Thank you for listening.